Section 2. Boom.
I don't think it did. There we go. Okay.
I think I'm no longer talking to the thing. There you go.
Okay.
So this is our section 2. We've changed it from "Do you give a bleep" to a science-based.
Or at least so far, science-based.
Yeah, Gesundheit. It's cedar season.
Oh, yes.
So this is our science-based. Carissa explains it all. It turned into too much death when we were doing "Do You Give a Bleep." It's kind of a downer. Now we're doing dark energy.
Dark energy. That was our topic for this week after last week's dark matter topic. And you expressed an interest in dark energy, and I told you that was going to be its own
So now here we are.
explanation.
So Carissa's going to explain dark energy.
Alright, so dark energy.
But before you do, let me throw in my nugget summary so we can find out if I'm right or spectacularly misinformed.
Okay.
Alright.
This is going to be fun.
My impression currently is that dark energy is sort of the blanket name for whatever force is pushing the universe slowly apart. That it's the vacuum energy of the void between stars, for lack of a better term. And we really don't know what it is beyond
Well, I
that.
guess I don't need to do anything.
But that's like the fortune cookie version, and I'm sure you have
Yeah.
a much better.
Yeah, I found pictures.
There's pictures.
You wanted pictures.
I did. I said I need more pictures, less text.
Now, I will tell you straight up that good luck trying to find black and white pictures in science.
Okay.
Because you can't actually see anything if it's black and white.
Well, let's.
Because it's just so much information in a picture.
Okay.
Okay. Okay.
All right.
Alright.
Just no black and white lines. Go ahead. Do the thing. We'll do the thing. I'll critique afterwards.
Okay, so the background. Beginning of the 90s, there were two ideas of universal expansion. One was that the universe might have enough energy density to just stop expanding and recollapse in on itself. And the second was that the universe might have so little energy density that it would never stop expanding, but eventually gravity would act on it and it'd slow the expansion. Don't try to read it.
Two fairly optimistic ideas, in my opinion.
Yeah, the second one, doesn't it seem like, okay, so yeah, if it has an effect, wouldn't it eventually always stop and then reverse?
Yes.
Okay.
So that was, those were the theories, and nobody knew for sure which one.
Okay.
Not a clue. So, cut to 1998, the Hubble Space Telescope is studying distant supernovae, and it observed that the universe used to expand more slowly than today.
See, we could do pictures of the Hubble, because you can do NASA. All the NASA pictures, I believe, are public domain. We're totally okay to use pictures of the Hubble telescope.
Okay, well, I did not find a picture of the Hubble telescope, because it's a frickin' telescope.
Yeah, but you're talking to a photographer.
Yeah, I feel like it'd be fairly easy to cut together a slideshow that would
Yeah.
go with this.
Yeah, no, pictures. All right, keep going. So
This is science-based. You are not for. This is not a picture book.
this is totally going to be a picture book.
This is
is
not
great.
a picture book.
This-
Okay.
It's going to be a picture book because you can read the thing. But yeah, okay. So it observed that the universe used to expand more slowly than today?
Uh-huh, and the explanation they've come up for this is called dark energy.
Do you happen to know if they named
Wait, so
dark
it's actually
matter?
accelerating? We're being pulled apart in an accelerating manner?
See, there's a picture.
Excellent. That is an awesome visual.
See, now what this picture is over here on the right, or left, sorry. You've got the Big Bang, and as the universe has gotten older, it's expanded. Now, what it is the space between the matter is expanding. The matter itself is not expanding.
Right.
Okay?
Yes, I understand that.
Okay. So, picture.
But it's actually going faster now than it would have been after the Big Bang.
Yes.
Oh, that's weird. Oh, that's creepy. Okay.
Okay. So now, basically, the theory is there's 4 types of universes. There's the recollapsing, in which the mass density is greater than the critical density, so it collapses in on itself eventually.
Right.
There's the critical, where there's just the right amount of mass per unit volume, so basically it will stop expanding at some point and just be static. And then there's coasting, in which the mass density is less than the critical density, so it will keep expanding but at a slower rate. And then there's the accelerating, which is what the observations suggest.
Now, are these types of universes like mathematical models that
Yes.
we've developed?
Yeah.
But we've observed that we're actually doing the accelerating one.
Yes. And see, here is a picture of the 4 types. So you've got the recollapsing, the critical, the coasting, and the accelerating. And that one on the far right is
That is
what
also an excellent visual.
we are currently experiencing with the data.
Do you happen to know if they named dark matter or dark energy first?
That I don't know.
Because I'm pretty sure whichever came second was just bandwagoning it.
Yeah, I'm pretty sure it was dark energy because, dark matter they had come up with in like 1980.
Leave a comment. Let's settle this in the comments. And if you
This
haven't
was,
already
late
subscribed,
90s, so.
if you haven't already subscribed, subscribe now. But leave a comment. Let us know. We're not going to bicker about the history of things. Let's keep going.
Okay, so what did it just do?
What did it do?
I don't know what it did.
Hit play.
Okay. Wasn't aware that it shuts down on me like that. Alright, so that's the visual. And then here's the evidence of the acceleration of the galaxies. Now, the observations point to an accelerating universe. Per Newton's second law, force equals mass times acceleration. So if the galaxies are accelerating away from each other, then some unseen force must be acting on them. Because that's
Right.
as we established, galaxies
Right.
are mass.
Yes.
Cue background theremin cue at this point.
You know what? Pass me the thing.
No, you're not pulling out the theremin now.
All right, next week.
Wait, you have a theremin?
I have a
He does.
theremin. It's right there. Get it. Just grab it. Come on, grab it.
No.
Up there.
You
it's
are
right
not
there
plugging
on the
it
shelf.
in now.
Okay. All right.
Okay.
Next week we will have the theremin.
Okay, yes. We're
We will
So-
make the theremin noises next week during this.
Again, picture. We have a graph of what we should be seeing for each of those galaxies, and as you can see from the little supernova data, they're all along the line for the accelerating one.
Yeah.
Okay?
It's weird. It's creepy. It's creepy.
It's creepy. The universe is a creepy, creepy place.
It's a weird
There's a-
place.
very nihilistic big rip in our future.
Right? All right.
Alright. So next one. Come on. Why are you...
This is greatly improved from last week, by the way.
Yes. So here's another picture of an accelerated expanding universe. So it's pretty similar to the other one, but
Right.
little more data.
This is just telling us the same thing, but in a different way.
Yes.
Gotcha.
Okay.
And in science, it is always best to try to constantly re-visualize things, because most of these concepts are so big that no one graph can really capture them.
Exactly.
I feel like I had to read 20 different explanations of like relativity before it sunk in.
Can you do that one next week?
You want relativity next week?
Yes.
Okay.
Let's do relativity next week.
Okay, I can do relativity next week. I do touch on relativity here a little bit. Okay, so we can calculate the amount of dark energy because we know how it affects the expansion of the universe. Measurements of the cosmic microwave background indicate that the universe is close to flat, and by flat we don't mean like piece of paper flat. We mean flat as in Euclidean geometry flat. So parallel lines will never intersect. The angles of a triangle will always add up to 180 degrees. The corners of a cube will always be 90 degrees. That
Okay.
sort of thing. So that's what we mean by flat. And so then the mass energy density ends up equaling the critical density, and then the total amount of matter in the universe accounts for a little over 30% of that critical density. So, another picture.
I'm lost. I'm gonna let you finish.
Why are you lost?
I missed the whole thing. That's okay. Keep going.
It was basically just just an explanation of this.
Okay.
So this is what they've
So
calculated.
the universe is basically mostly dark energy and dark matter and just wait. How are dark energy and okay. I'm lost, so we're gonna clean this up next.
Okay.
Relativity will help.
Okay.
Well, it's like dark matter is stuff, and dark energy is not stuff.
Right. So then,
If that makes any sense.
but where's ordinary energy in this graph?
Ordinary energy is, well, what you mean when you say energy is still actually matter, I'm assuming.
Yeah.
Okay.
So.
Because even like when we think of energy, we think of like electricity. Electricity still counts as matter. Dark energy
Really?
means the
Yeah.
void in between.
E equals mc squared.
Yeah.
Energy equals mass times the speed of light squared.
Yeah, but that means that
What's
they're
energy?
different things. But you're telling me they're the same thing.
They're related.
Okay.
Mass can be energy, and energy can be mass.
Okay.
Okay.
Keep going.
So Einstein's theory of general relativity predicts that this energy will have a gravitational effect. So pressure within a substance contributes to its gravitational attraction for other objects. Now dark energy would need to have a negative pressure equal to its energy density to cause the expansion of the universe. Okay?
Right.
Okay.
Right. I
Okay.
follow.
Okay. So the possibilities. 1, dark energy is a property of space. It's just there.
Just how it
It's
works.
just how it works.
I reserve
You
the
know,
right to add a
it's-
fourth to this
you know,
list.
One of Einstein's gravity theories involved a cosmological constant, which would actually kind of explain this a little bit, but it didn't really work with the knowledge they had back then, so he scrapped it.
Okay.
So now they're kind of revisiting that to see if that
Really?
that makes more sense.
That's a brand new data point for me. That's fascinating. The idea that they may have found their way back to the cosmological constant.
So yeah, they're exploring that. They've tried thinking that it's like a quantum property, but when they did the calculations, they were off by an order of 120.
Wow.
So, yeah, to be that far off from it probably means it's wrong. Or 2, it could be a new dynamic fluid or field that we just don't know about, that we had no clue about.
Regal cat.
Or that we simply don't have the instrumentation necessary to detect.
Exactly. So, there's that. Or it could be a completely new theory of gravity altogether.
Which is always possible.
It's just always possible, but it would,
Yeah.
at the same time, it would kind of turn everything we know almost on its head. So,
But there is that sort of, Damoclesian sword hanging over physics, where
Yeah.
everyone knows relativity and quantum mechanics don't
agree.
really agree. So clearly we're missing something.
Yes.
At some point, we're either going to add to those theories or
Mm-hmm.
have to scrap them and replace them with something more comprehensive.
Right, right. So yeah, just more and better data is needed in order to narrow down what it is.
Gotcha.
Okay.
I really think it's metachlorians. All right.
All right, I would agree. That was awesome. It's really so.
All right, give me a lap.
I might be slightly jumping ahead to the shout out, but I feel like it's appropriate. I've been reading His Dark Materials trilogy by Philip Pullman, and it is a fictional story in which dark matter and dark energy are very prominent plot points. Because it's a story about parallel universes and someone discovering a brand new instrument that can detect dark energy and realizing that they can manipulate it to open holes between parallel universes.
Nice.
And it's just awesome.
Nice.
Anyway, carry on.
Okay.
Apparently, Farewell My Love is following me on Twitter. Sorry.
Okay.